We continue learning workbook page 59 with this final problem from section 4.1. Solve the system of equations by a method of your choice. 6x plus y equals 1, 3y equals 3 minus 18x. Okay, once again, I've labeled the two equations as equation 1 and equation 2. Let's go through the steps of determining which method we should use to solve this system. We notice that there are no fractions this time, so we can go directly to looking at the coefficients. I've underlined the terms with variables. The x terms have been underlined in red, and the green terms represent the terms that contain the variable y. Let's look at the coefficient of each in the hopes that we find a coefficient that is a 1 or a negative 1. All right, here we go. This red term has a coefficient of 6. This red term has a coefficient of negative 18. This green term has a coefficient of 3. This green term has a coefficient of 1. Aha! We do have a term whose coefficient is 1 or negative 1. It would be this term in equation 1. So our objective is, let's use substitution method to solve this problem, and let's solve for this variable. Okay, 6x plus y equals 1. To solve for y, move this term to the other side. We get y equals 1 minus 6x. Or if you like, you can write y equals negative 6x plus 1. Now, we call this the substitution method because we are now going to substitute what y equals from equation 1 for y in equation 2. You always substitute into the other equation. So this value of y, this expression for what y equals, is going to go into our equation. So we get 3 times 1 minus 6x in parentheses equals 3 minus 18x. The parentheses are required because we are replacing this y with something new, and this y has a multiplying neighbor, therefore meaning parentheses are required. All right, now we distribute, and we get 3 minus 18x equals 3 minus 18x. This is the moment where we start to realize we're probably dealing with one of our special cases. Notice something. The left side and the right side are identical, which means this is probably going to be an identity, and therefore the right answer will be all real numbers. All right, let's pretend we don't notice that and continue on. Let's collect all terms that contain a variable on one side and all terms that do not on the other. And remember that when a term changes sides, it changes signs. So I get 3 minus 3 equals negative 18x plus 18x. 3 minus 3 is 0. Negative 18x plus 18x is 0. So I get something with no variable in it, which happens to be a true statement. This is an identity, and therefore the final answer for this problem is all real numbers that satisfy either one of these equations. So we have to write that in a very specific way. We want all of the ordered pairs that make either one of these equations true. So the way we're going to write this is by writing one of our equations as our answer. So the set of ordered pairs that satisfy the equation 6x plus y equals 1 is our answer to this question. Now in my math lab, how are they going to ask you to enter your answer? So take a look at your learning workbook. You'll notice that there are 3 answer choices. A says there is one solution, and then you provide an ordered pair. B says the set of the system, the set of all ordered pairs x comma y such that, followed by a blank. And then the third option says the solution set is no solution. So for this problem, we're looking for bubble choice B. So we're going to bubble in next to letter B where it says the solution of the system is the set of all ordered pairs x comma y such that. And then what we have to do is put an equation in the blank that follows. What equation? Either one. They both represent the same collection of ordered pairs because when you graph both equations, they are identical lines. So you could write 6x plus y equals 1. and that would be a correct answer. Or, if you prefer, you can write 3y equals 3 minus 18x. Or, if you prefer, you can write this equation, y equals 1 minus 6x. Pretty much any equation anywhere in your solution that still contains an x and a y in it would be a correct answer to this problem. It's up to you which one you would like to use. Now, computer programmers have a difficult task, which is to learn to recognize whether an answer is correct or not. So it's very common in an algebra class to request that students present their final answer in the slope-intercept form, simply because there's only one way of writing it. And so if we took our solution here, y equals 1 minus 6x, and we swapped the order of the two terms, we would get y equals negative 6x plus 1. This is even a fourth correct answer, but what it makes it so important is that it is the slope-intercept form, and it's the only answer if the instructions ask you for slope-intercept form. So always read the directions for the problem that you are solving, because you may find that this is an extra skill that you have to have in order to get a right answer.